Hello guys, so today we are here to solve our daily LeetCode challenge for the day, and this challenge is minimize jar. Okay, in this we are given two positive integers nums1 and nums2. Okay, and we have to find a positive integer x. Okay, so the integer that we need to find is the integer x. So the condition with the integer x is that x has to have the same number of set bits as num2. So what is set bits in num2? Num2, if you convert num2 into binary representation, a bit can be either 0 or 1. The count of you know bits having value 1 is the number of set bits. So same count, uh, count of 1 bits, count having bit value as 1, that count is the number of set bits. So x has to have the same number of ones as the number 2 in its binary representation has. And also the other condition is that XOR num1 is minimal. Okay, so these are the two conditions. Okay, now to understand this, how are we going to solve this? Okay, first of all, our high level approach will be, first we will find the count of set bits in num2. Okay, and after finding it, what we will do, that we will also try to figure out, how can we construct x so that the value of x XOR num1 is minimal. Okay, so this is the two condition. Now to fulfill the first condition, let's declare one variable int count set bits is equal to 0. We'll take the second number and then iterate a loop on it. So till num2 is not equal to 0, we will perform an operation on it. And what is that operation is? This operation is ANDing that regular, that num2 and storing that updated value back into num2. So we'll be ANDing num2 and num2 minus 1 and again put back the value back into num2. Okay, and then what we will do, that we will be incrementing count set bits. Okay, we'll be incrementing count set bits. So what is this line number 9 is going to do? What is this piece of code is going to do? So this will clear the rightmost bit. Okay, or the least significant bit is made 0 by this line. Okay, and the number of times this happens is actually equal to the number of set bits in num2, and we are incrementing this count set bits every time we are setting it to be equal to 0. Now with this, what we'll do, that we will after getting the count of set bits in num2, what we need to do, we need to create x in such a way that x XOR num1 is minimal. So in order to do that, what we need to do is that we will put ones in x at same position where it is where it is 1 in the binary representation of num1. What I mean by that, if you convert num1 into its binary representation, some bits will be 1, some bits will be 0. Okay, so we are at x also will be putting same bit position as 1 where it is 1 in num1. And how are we going to do that? We are going to do that, of course we need to figure out which bits are set in num1, but we cannot do it from the least significant bit position. Why? Because if we set least significant bit position as 1 in x and num1 both places, then the value may not be minimal. But if we do it in the most significant bit, because we all know that how XOR operation works. So XOR works, okay, if the bits are same, the result is 0. If they are different, then it is 1. So if it is same, the result is 0. If they are different, then it is 1. So why we are putting in the same position where num1 is 1, in x also 1. Why? Because then the result will be minimal, and we are doing it from the most significant bit position. So we are doing it from int I is equal to 31st. So this is the most significant bit position, and then gradually we are going towards 0. Okay, and we are doing decrementing I each time. Okay, and we are checking if num1, first of all we'll do right shift I times. Okay, and then after doing right shift I times, we'll be doing and with 1. Okay, if it is set, so if it is set, then on ANDing with 1, it will return, it will be equal to 1. And if it is equal to 1, okay, if it is equal to 1, okay, then we'll be doing doing this. So what are we going to do in this? In this, what we will do, that we will be the x, the ith bit will be set. So to set the ith bit, we'll have to use OR operation. So we are doing XOR 1 moved, we are moving one right side, right shift, we are shifting one right shift I times, and with this, and so first of all we'll have to check, we'll put a check here, that if count set bits is greater than 0. If it is greater than 0, then what we will do, like this, and then minus count set bits. Okay, okay, so this is going to, so what we are doing, we are starting from the most significant bit, and that is 31st bit position, and then we are gradually moving towards the 0th bit position. At every bit position, first of all we are checking whether num1 is equal to 1. How we are checking this? So we are moving that 31st bit position to the unit place, and then doing AND with 1. So doing AND with 1 is the shifted value of num1 and 1, they both will be ANDed, and if the result is 1, it means that the num1 at ith bit position is 1. So if that position is set, and if count set is 1, if it is greater than 0, then what we are doing, we are ANDing that position of x with 1. However we are doing it, we are using OR operation, and in OR what we are doing, we are doing XOR with 1 shifted that many bit position towards the right, and we are decrementing our count set bits. So this is the thing. And then after this, what we are doing, that we are using this for loop again. So here what we can do, if at all the if count set bits is equal to 0, okay, if it is equal to 0, no worry, we can directly return our thing. So first of all, I'll have to declare one x here, and x is equal to 0. This is the x that we are using here in this line. Okay, So if count set bits is equal to 0, then we'll have to return our x, because we have constructed x and utilized. Now x is having the same number of bits as num2, because count set bits is the count of number of bits which are set in num2, and now count set bits is equal to 0, and we have utilized all the that many counts in creating an x which is minimal. How we are creating minimal? At same position in num1 where it is set, we are also setting that position as 1 in x, because then the XORing effect will be those same bit position, because they are all having the value 1. They will be uh, those bit position will be giving the value, will be having the bit value 0, and eventually the value will be contributing nothing to the total value, and that's how they'll be becoming minimal. But in case it is possible that some bit positions are still left, so in this what we'll do, we will go from the least significant bit position, and we will be going towards I less than 32, so we'll be going towards 31. And then what we will do here, so we will be using this AND also. Count set bits is greater than 0. Okay, after doing this, what we will again put a check if x I, okay, and I and 1, okay, and 1, x right shift I times and 1. If it is equal to 1, it means, so we don't want it to be equal to 1, because those values we have already set in the previous thing. So what we'll do, it should be equal to 0. If it is equal to 0, and those positions will be we'll be using this count set bits. So to do this count set bit, what we'll be doing, XOR one like this, and then again we'll be decrementing count set bits. I hope this is clear to everyone. Okay, in this loop, what we are doing in this loop, we are using this loop just to set the same bits as num1 in x as well, x. But here what we are doing, that if some count set bits is still not equal to 0, then in this what we are doing, we are now considering the bits which in x which are 0. So those bits also we are setting and decrementing our count set bits each time we are going towards the most significant bit of 31, because this is moving from 31 and then coming to 0. It may be possible that we have not used all 32 bits. So once we are going back in this direction, we will be exhausting all 32 bits. Count set bit value can be at most 32 bits. Okay, let me mention this here. Okay, by the count set bit value can be at most 32 bit, because 10 to the power 9, okay, this is not 10 to the power 9, this is, I'm using 10 to the power 9, in that sense I'm using that symbol. 10 to the power 9 value has at most 30 bits, but it has at most 30 bits. Just let's mention this. So this first time we are going from the most significant bit towards the least significant bit, and then and first time we are checking if in num1 that bit is set or not. In second time we are going from the least significant bit to the most significant bit, and we are checking whether that x bit position is equal to 0. Okay, now after doing this, what we will do, we will return x. Okay, so I hope if you are able to visualize these things, what is happening in these two loops, then this problem is very easy. Okay, so I hope you are able to, with my explanation, you are able to imagine what I'm trying to say, and see that if the binary representation having 32 bit, first time we are going from the 31st bit towards the 0th bit, and then second time we are going from the 0th bit to the 31st bit. First time we are setting same value in x which are set as in num1, and second time what we are doing, we are setting those values of x which are you know not set in the first time, so those are still 0. We are setting those values, and then this time we are moving from least significant bit towards the highest bit. And after doing this, definitely what we are going to get is the minimal number, because the construction itself guarantees that this number will be minimal. And once we run our this solution, let's see how it's performing. Perfect. Perfect. So with this, I thank you one and all. Happy coding, best wishes. Keep rocking.